Alright, this is a video dealing with magnetism. So we're going to go through this PowerPoint, just kind of hit a few highlights, and then we will touch base with kind of some things we've covered in class just a little bit, and on induction and stuff like that, and just kind of review just a tiny bit. So some key things: magnets are polar. They have north and south poles. The Earth is actually one big magnet. We have our geographic poles and our magnetic poles, but they're opposites. In other words, our geographic pole is our geographic north pole is the direction we call north, but that's also close to our magnetic south pole, because the north end of the compass is attracted to a south magnet. So the south magnetic pole is the north geographic pole, or they're close. They're not exactly the same, because remember, we have that thing called magnetic declination, and magnetic declination is that little bit of difference we have between those values, and the values are different depending on your latitude, as far as wherever you are, as compared from the North Pole to the equator, or equator to South Pole. So anyway, those are different. And we talked about how Midland is a railroad town, and how you can kind of tell that declination based upon that in an earlier video, as well as in class some. So one thing that that we're going to talk about in this deal is we're going to talk about how magnets can be used to induce electric current and to produce motion from an electric current generated motors, and how they produce force on a moving charge. So we're going to do this pretty quickly. We talked about solenoids in class, and this is an example of one. Remember, it's a coiled wire that you put electric current through, and because of that you get a pole. So there's the north pole on that, here's the south pole on that, and if we put a magnet through there, we can generate an electric current, because we are opposing this other magnetic field. And when we do that, we can get we have a force acting on that. We are we're actually making a magnet move and repel, or be attracted to different ends, and we cause something called magnetic flux. And we used one of these in class the other day and talked about how that happens. So again, so solenoids, they can produce a magnetic field based upon electric current going through, and they're coiled up like this. Okay? And we do use those. They're used in cars and stuff like that, as well as sprinkler heads. I mentioned that when we were talking the other day, and just because of the opposing magnetic fields. Okay? Now, generators can produce either AC or DC current. Okay? DC generators use a split ring. It's kind of like a slip ring that we talked about with AC, but the ring is split in half, and as that end moves up, this other side is moving down. At that point, whenever it's going across this field, it's going to have the most amount of field lines cut, because remember, the magnetic field is moving from north to south always, and because these lines are going this way, and if this loop is going up and down, it's going to cut across, perpendicular across these. That's whenever you generate the most amount of electricity and most amount of flux. Okay? That produces a current, and if it's this type of a generator, it's a direct current. Alright? Okay, so we're going to kind of stop here for now. I'm going to do another video where we talk about AC generators, and hopefully we can kind of get these put together in small segments.